This is video 4 for week number 8. So let's begin by defining what we mean by a contractive sequence. Okay, so a sequence xn of real numbers is said to be a contractive sequence if there exists a constant c which lies between 0 and 1, such that the distance between xn plus 2 and xn is less or equal to c times the distance between xn plus 1 and xn. I'll say that again. The distance between xn plus 2 and xn plus 1 is less or equal to c times the distance between xn plus 1 and xn. For example, if n is 1, then you have the distance between x3 and x2 will be less or equal to c times the distance between x2 and x1. If n is 3, then you have if n is 2, then you have that the distance between x4 and x3 is less or equal to c times the distance between x3 and x2. And this inequality must hold for all natural numbers n. So if this inequality holds for all natural numbers n, then we say that the sequence xn is a contractive sequence. Okay. The next theorem tells us that every contractive sequence is a Cauchy sequence and therefore converges. If a sequence is contractive, then that sequence must be Cauchy, and since every Cauchy sequence converges, then every contractive sequence also converges. So let's look at the proof. Assume that xn is contractive, right? Then, by definition, the distance between xn plus 2 and xn plus 1 is less or equal to c times the distance between xn plus 1 and xn. All right. But then, again from the definition, you have that the distance between xn plus 1 and xn is less or equal to c times the distance between xn and xn minus 1. But you already have this c here, right? So then you get c squared here. Continuing that way, you end up with this is less or equal to c to the power n times the distance between x2 and x1. Now, we want to show that xn is Cauchy. So once show that xn is Cauchy, first of all, we are going to write down the distance between xm and xn. Okay, so I'll just write this as the magnitude of xm. I have minus xn here. Now in between here, introduce minus xm minus 1 plus xm minus 1 minus xm minus 2 plus xm minus 2 up to here. I have minus xn plus 1, then plus xn plus 1, then you end up with minus xn. Now you use a triangle inequality to get that is less or equal to this expression here. Okay, here we're simply applying the triangle inequality, and then you use the fact that the distance between xn plus 2 and xn plus 1 is less or equal to c to the power m times the distance between x minus x2 and x1. So we are going to use the fact that the distance between xn plus 2 and xn plus 1 is less or equal to c to the power n times the distance between x2 and x1. So when we use that fact, we end up with that expression is less or equal to this one here. Let me clear it first. So we end up with this sum here, okay, is less or equal to this sum here, okay, where we are using the fact that the distance between xn plus 2 and xn minus 1 is less or equal to c to the power n times the distance between x2 and x1. So just factor out c to the power n minus 1, and then you get this expression here, and then write it in summation notation, okay? And then this will be less than this one here when you take the sum up to infinity, okay? Now you note that this will be a geometric series, okay, with the c here, which lies between 0 and 1, and therefore this is a convergent geometric series. It converges to 1 over 1 minus c, okay? And so we have that if m is bigger than n, then the distance between xm and xn is less or equal to c the power n minus 1, okay, times 1 over 1 minus c times the distance between xn times the distance between x2 and x1. So we call this one inequality 1. We'll need it on the next page. Now you see that if the distance between x2 and x1 is 0, then the whole of this one will be 0, and therefore the distance between xm and xn will be 0, and therefore it will be less than n epsilon bigger than 0, right? And so in that case, there's nothing to prove. So we'll assume that the distance between x2 and x1 is not 0. Now, if the distance between x1 and x2 is equal to 0, then there is nothing to prove, okay? If the distance between x1 and x2 and x1 is 0, then there's nothing to prove, because I've written here inequality 1 from the previous page, okay? So then if you look at this inequality 1 from the previous page, if the distance between x2 and x1 is 0, then the whole of this will be 0, and therefore the distance between xm and xn will be 0, and this will be less than every epsilon bigger than 0. So there's nothing to prove there if the distance between x1 and x2 is 0. So that is what we are saying here, that if the distance between x1 and x2 is 0, then there's nothing to prove. So let's assume that the distance between x1 and x2 is bigger than 0. Now, since c lies between 0 and 1, we see that the sequence c to the power n minus 1 converges to 0. That this limit is equal to 0, because c lies between 0 and 1, and therefore this limit is equal to 0. Okay, as n goes to infinity, c to the power n minus 1 goes to 0. And therefore, given epsilon bigger than 0, right, there is a natural number n such that if small n is bigger or equal to that natural number n, then the distance between cn minus the power n minus 1 and 0, right, which is simply c to the power n minus 1, okay, will be less than this number here, which is a positive number, right? Yeah, because this limit is equal to 0, so the distance between this and 0 will be less than that number, so long as n, small n, is bigger or equal to capital N. There will be that capital N with that property. And therefore, if m and n satisfy this property here, small m and small n satisfy this property here, then we have this one from the previous page, which was inequality 1, right? Okay. And then because both m and n are bigger than capital N, then we have that this one, this one, okay, from here, okay, will be less than epsilon, will be less than this, okay? Then you simply multiply it by this. So all you do is replace this one, okay, by this term here, okay, which comes from here. And then you see that this will be equal to epsilon, all right? Let me take this away so that we see it properly, okay? So you see that this, so I've just replaced this, okay, with this expression here, and we get that this is bigger. So the whole of that times this, right, okay, will give you epsilon. So the conclusion is that if m and n are bigger than capital N, with m bigger than n, so if you have m and n, then either m is bigger than n or n is bigger than m, all right? So if m and n satisfy this property here, then the distance between xm and xn will be less than epsilon, and so we conclude that the sequence xn is a Cauchy sequence and therefore converges. So the conclusion here is that every contractive sequence converges. Every contractive sequence converges because it is a Cauchy sequence, and every Cauchy sequence converges.